How did I achieve this much stability? Well, make sure you watch the video to the end to find out. Welcome back to the channel. If you're new, you're welcome as well. Make sure to subscribe and hit that notification bell. If you haven't seen the last video about this project, make sure to check it out before you continue watching this one. Let's get into it. I started checking for play in the swash plates and I discovered a slight play between the upper plates and the ball center. I went on to CAD and redesigned the upper plate a bit by reducing some of the tolerances between the ball center and the upper plate, which I 3D printed with the same ABS filament that I've used previously. It is basically the strongest filament that I have in stock. There are a couple of some other components that I'll be replacing, like the main rotor motor to a higher kV one, and as well as the receiver to a much smaller one to save some weight. Let's begin to install the new components. Before installing the new motor, I need to flip the motor shaft upside down so as to accommodate the pinion gear. So this is the pinion gear installed, and as you can see, the motor shaft has been flipped. The motor was installed and it fits perfectly well as the swash plates that I previously modified. So there's little to no play this time around, and the only play that I is seeing is actually coming from the bearing which connects the upper plate and the lower plate together. Without further ado, let's get into the test flying. Now it wants to start. Yep, I definitely broke something, and the helicopter continues to spiral about a circle, and it was very unstable. And what I broke was the landing gear, which I ended up replacing with a different kind of landing gear. This landing gear came from an old commercial helicopter that I used to have, and it's quite rigid and sturdy. It's able to take any kind of fall or push that I give to it. I did a couple of more adjustments as well to try and get it into fly much better. So let's get into the flight test. After so many tries that I tried to fly with the onboard gyro, I could not get this thing to fly much stable with the gyro. So I decided to design a flybar system that provides a gyroscopic stability. Not much change in the rotor head design. I basically just added the flybar system to it and as well as the paddle itself. So I went ahead and 3D printed everything and I coupled the components together. I would just like to talk about the Flybar system that I've designed and wanted to use. I initially designed the paddle to be non-F4 shaped so as to kind of like give a test for the gyroscopic effect to see how much stable the rotor head system can become. So I'm basically using a push rod with threaded ends to kind of like put this together. And I also did a balance test on the pad because, of course, you need to make sure it is balanced. Because if one side is heavier than the other side, you are not going to have the stability you want. So I put everything else together, including the rotor edge system. A more detailed video is in the previous video about this project. So it's basically the same thing in coupling it together. Once everything is ready on the Flybar system, I took out the old one and I did a couple of test fits on the rotor head. And you can see here I already have everything together, but I discovered an issue. As you can see, the twist that is happening currently is due to the fact that the linkage between the fiber and the rotor edge system doesn't have like a rigid support like the lower section does. So I will be basically be adding the same thing that I have on the lower section to the upper section so as to prevent that twist, which I did here. It's just a couple of 3D prints components that I had it. So let's give it a test now. So apparently I managed to get rid of that cyclic spiral motion. But however, with the paddle that I had previously, I wasn't having any controls on the flight. So I reshaped the paddle into an A4 shape and I added a bit of a counterweight at the tip to kind of like help with the gyroscopic stability. And I decided to give it a test. So what has been happening here is that despite being able to like at least maintain a stable hovering, my yaw control was terrible and the gain for the rotor was very, very horrible. So it kept violently shaking the heading, which makes it difficult to control. You understand when your heading is constantly changing and you are trying to like kind of like maintain it. So I found out later that my tail rotor blades were slightly bigger, so it's kind of like overcompensating because despite the fact that I tried to reduce the gain, I wasn't able to get a decent yaw control. So I ended up reducing the length of the blades of the tail rotor since the tail motor RPMs were also high. So that was the most reasonable thing to do, and apparently it worked better. Right, I was able to achieve a better flight now, but I wanted something much better. So I increased the weight at the tip of the paddle to further create a gyroscopic effect. So let's give it a go. You could hear me saying that wasn't me. Apparently, as soon as I tried to take off a bit, the helicopter shoots off rapidly. So I didn't understand what could have caused that. So I ended up crashing into some of the frames there, breaking the tail rotor propeller, and the main rotor shaft was bent. So as well, me and my body spent the night replacing that. With all the tests that I've done, I observed that my control inputs wasn't that great, and it's wasn't stabilizing as much as I wanted. So I practically increased the size of the paddle to create much more gyroscopic effects and a much more effective controls. I'm just really glad I was able to achieve this much stability at the end, and it was quite a challenging project for me because I was basically building everything from scratch. And pretty sure you guys like the video. And if you made it this far to the end of the video and you haven't subscribed, do make sure to subscribe now and hit that notification bell. And also make sure you like and share this video. Thank you for watching. I'll see you in the next project.